Hello there and welcome to my channel. Now I often travel overseas, and when I do I tend to take a Bluetooth speaker and a multi-band radio with shortwave. And I was thinking, wouldn't it be great if I could stuff less in my suitcase by having both features in one device? And then as it happened, some of the YouTube channels that I follow in the shortwave community were going on about this new radio on the market that not only is a reasonable radio with shortwave, but it also had Bluetooth, it had media player, it had good audio reproduction, which is really powerful, audio recording to an SD card, and I had a phone app, and all that for less than $70 US. At that price, well, I just had to get one. So the one I bought was the HanRongDa HRD-A320. Now, looking at the other reviews, I can see that it's available in at least 3 other brands, but as far as I can tell, it's exactly the same radio, same hardware, and probably comes out of the same factory. So I received one today, so I'm quite excited to do a teardown, and then I'm going to do a hardware review, and then I'm going to do an audio power test to find out how good does it really sound, how powerful is it, and what's behind it. And I'm also going to have a look at any potential upgrades, but I'm not going to do a radio performance review. That means I'm not going to review how good it is at receiving distant signals and all that sort of stuff, because there's so many other reviews out there which just focus on that. But none of those reviews, from what I could see, do a teardown. So that's why I thought I'd do this little video today. Before we get started, I'd like to give a quick thank you to today's sponsor, which is PCBWay. PCBWay are renowned for producing high-quality PCBs at low cost and with fast delivery times. They have outstanding manufacturing capabilities, including flexible and HDI PCBs, and can even assemble the boards for you. They have a very easy-to-use web page that can provide you with a quote within minutes of uploading your Gerber files and selecting your PCB manufacturing parameters. In addition to PCBs, PCBWay have other services including CNC machining and 3D printing. I'd also like to mention that if you're working on a great electronic or mechanical project at the moment, now could be a perfect opportunity for you to enter into PCBWay's 6 Project Design Contest. The contest is running until the 15th of January 2024, so you still have time to make an entry. So take a look at PCBWay.com for further details. I got this for around $70 US. Where you are, of course, that might be different. I bought it from AliExpress, and I think if you look through there, you'll find this under a number of different brands, as I was saying earlier. But if you shop around, you should get one for around that price. Now the box itself is quite small, so the radio must be really compact. I dig those retro looks. It reminds me of like a military communications style receiver from the 1980s. What features it got? New design, oh fantastic. Multi-band radio, TF card or SD card, Bluetooth, SOS alarm, okay, flashlight, bass sound, audio in, sleep setting, alarm clock, app control, digital keys by app, whatever that means, record by app, time service by app, and mute. Alright, so look at the specs on the back. FM 64 to 108, VHF, this is interesting, 30 megahertz all the way up to 200 megahertz. Medium wave, or AM as you call it in the States. Shortwave 3.2 megs to 22 megs, airband, weather band, and all those are power consumption. 4 ohm 5 watt speaker. 5 watt speaker is impressive in a small radio. Version 5, I guess that's Bluetooth, 3.4 volts, I don't know what that is. Let's get it open. Oh, it's got a case. Oh, I like things with a case. Yeah, that is handy for traveling. quite small. Okay, so the radio itself must be quite small. It's quite a thick manual for a radio. It shows how many features it's got. And the specs again, it seems to be quite comprehensive. And it looks like this manual is all in English so far. That's unusual. Normally you've got multiple languages, so all that is in one language. That's quite detailed spec document. That's good. There's the specs again. Oh, that 3.4 volts is the minimum working voltage. 2000 milliamp hour battery. Oh, it's got a separate manual for the app. Okay, I won't go into this too much. Yeah, that looks good too. What else have we got in here? Strap, alright. Power cable, charging cable. Is that mini? Oh, it's USB-C. Oh, that's good. A brush. A brush and a screwdriver. I understand the screwdriver maybe, but what? Why is there a shaver in there? Battery, okay, 2000 milliamp hour. So 18650. That's well wrapped. In a box, in a case, and in bubble wrap. Can't ask for more than that. Oh, it's so cute. There's a speaker on the back and the front. The finish is interesting. It's like spray painted plastic. It's kind of got a glossy look to it. It's like it's lacquered plastic. It's weird. I think that's all the screws out. Note that you got to take the sticky feet off the bottom and the label. There's a little label to take off. And we're open. Oh no, I've pulled a cable off. Spoke too soon. I think that's one of the cables attached to a ferro antenna. Let's get all those antenna cables out of the way. We've got one FM stroke shortwave cable and two fine cables which go to a ferrite rod antenna for your medium wave or AM. Look how thick those power cables are. And you see you've got a little speaker cabinet. On the left you've got like a passive radiator, and then on the right you've got, what is that? Pieces of metal around the speaker, sorry, around the battery case. Why they got pieces of metal? And a lump of metal. Well, looks like it. What's that there for? Shielding or something? No, you wouldn't have shielding that thick. And why that lump of metal? Make it heavier? You give you that quality heaviness. 4 ohm speaker. That's 5-watt jobby. You see the little sealed speaker cabinet on both sides with the passive radiator on the left and the speaker on the right. Okay, let's get these super high current cables separated, and then we stand a chance of getting the PCB out of the way. It's weird that I've got these really thick power cables capable of bringing plenty of power into the PCB. When you think about it, the only power or significant power going out of the PCB is to the speaker, and look how thin those cables are. I don't understand why those power cables are so thick in a portable radio. Let's see how to get this PCB out. Do I need to remove those knobs? Okay, so I've taken the knob off and I've got the screws out. There's the reflector for the flashlight. What else do we have to take it off? Okay, we need to remove those fine cables there. I think they're the LED backlight for the LCD. Okay, we'll get this out and have a good look around, have a good gander. I'm gonna have to remove those speaker cables first. Those tiny speaker cables. Notice all the bits of foam in the case. Stop vibration, I guess. Okay. Oh, I've got a little potentiometer on the underside for the manual tuning. The buttons. Okay, there's the passive radiator you can see. And the ferrite core antenna and the back part of the little integrated speaker cabinet with foam surround. Yeah, and telescopic antenna, and the 3 wires going across to the main board. Now that block of metal is weird. That looks quite a significant weight. No wonder the little thing's so heavy. It did feel quite weighty in the hand. You can see how these front and back go together, and that seal around the rear part of the speaker cabinet provides a complete sealed speaker cab. Speaker in the front, passive radiator in the back. I'll try and get that lump of metal out, see if there's another use for it which is not obvious. If you got any ideas what this is for, please leave it in the comments. I've never seen that in a radio before. And there it is. Yeah, it looks like just a block of metal. Why? Why? In case you're interested, 61.5 grams. And here's the PCB out. Have a quick look around, a quick gander. The first thing to note is this DSP Air 3 little daughter board there. What is that for? Looks like it's got a crystal on the front. Is that a crystal module or some sort of bandpass filter or something? The other side doesn't seem to have a lot. It looks like maybe some transistors, some diode packs, passive components there. Not a lot going on there. You see you've got the connections to the ferrite core antenna, connection for the FM and shortwave antenna. I guess on the other side we'll have our radio IC. There she is. There's the connections to the AM antenna going to the radio chip, which is a, can't quite see it focus there, AKC6958. Got a crystal connected to it. And some passives around the chip on the other side, around the radio chip. Some gunky stuff. Hold those capacitors still while it's the speaker's doing its thing. Connections for the LED backlight. 74HC595. I think that's a shift register, if I'm not mistaken. Whether that's being used, I didn't expect to see that there. LEDs. These LEDs will be used to light up the dial for the manual tuning. I've seen it give a nice soft glow. What's this? This is looks like a rotary encoder. Oh, that's for the fine tuning. What else we got on the other side? That's the potentiometer for the manual tuning. There's 4 LEDs again. What else have we got around here? That looks like the controller, microcontroller. There's crystal, there's clock. The control buttons on the front panel. What is that controller? ABCXKC14B. 5C, never heard of it. What else have we got? So the connections go there to the microprocessor from the buttons, or the controller from the buttons. What else have we got there? There's a crystal on the back. Is that 26 megahertz? Looks like it. Oh, that's the Bluetooth antenna. Recognize that sort of PCB. Yeah, so that'd be a Bluetooth. That crystal might be something to do with the Bluetooth as well. A lot of passives around it. Battery connections. Oh, and that would be the lithium-ion battery charge circuit, CL4056. That's quite a common device. The Type-C connector, and then we got jacks for headphones and auxiliary input. What's that P1? Not populated. Any idea what that is? Let me know in the comments. What? That must be the Class D amplifier. Yeah, this one is, I think, is the audio input jack. A couple of capacitors there. While decoupling the power supply lines around the Class D amplifier. What else we got? Oh, another shift register. Oh, I think those are being used to drive those LEDs. Oh, that's quite smart. So the controller must clock in the data to switch the LEDs on and off into these shift registers, and then the output gets enabled and the data passes the LEDs to switch them on or off. That's pretty smart. This would be the LCD driver, and we've got that edge connector for the LCD. Well, we've got a HT1621B. What else we got? I guess that must be pretty much it. Well, there we have it. Cool. Let's analyze this. The key components here for you, so you can see how this all fits together. So starting off with the radio chip is the first device. So we've got the 6958 DSP radio chip connects to this ferrite antenna, and also a telescopic antenna with shortwave, FM and VHF input. Now I couldn't find that device exactly for the data sheet. I did find the 6959, which is just one number up. You can see it's stereo TV, medium wave FM radio chip, and the frequency ranges seem to correspond more or less to the spec on the box. So it must be a very similar device. 32K crystal. He's just got a clock and data input, which is what you expect. It could be then controlled from the controller IC. Okay, various information about its modes. Built-in PA, what is that? Okay. Specs as expected for such a chip. Now this looks like the minimum feasible circuit to make a radio out of this thing. You've got the ferrite rod antenna connections, and then you got your telescopic antenna connections to both FM and shortwave inputs. And then what have we got? Okay, so you've got a voltage reference pin. I see. So that was set a reference voltage for this voltage divider, which would be used to produce a voltage input to an internal ADC for selecting your bands and whether you're on FM or AM, etc., etc. Quite a common way of doing it in these devices. I don't know what that is. PVC, whatever that is. This potentiometer would be the tuning, so you've got another voltage input from the voltage reference to another ADC to select the frequency. Then that digital input and clock will connect to the microcontroller. This ABCXK145B. Now I couldn't find that, but I did find something which was referenced from that part number, which is the EB003 which is a 32-bit RISC microcontroller in a radio. And look at all its functions. Obviously, it's dedicated for radio applications. And so you've got analog to digital converter input, your IIS digital audio interface, SPDIF interface, card interface, USB 2, GIO input, keyboard input interface, display interface. It's also got an FM tuner. Okay, so this radio actually has two tuners, Bluetooth 5.2. Okay. Second FM tuner. Two tuners, FM tuners and one radio. Okay. It's got receive signal strength indicator. Yeah, I've seen that featured in other videos, which shows the signal strength on the display. 16-bit stereo digital analog converter. Well, that's quite good spec. Equalizer. Yeah, I've seen equalizer functions on this radio in other videos. 48K kilohertz sampling rate. That's good. Built-in headphone amplifier. And then it's got the kind of features you'd expect a controller to have. Two SPI interfaces, SD card interface, the audio IIS audio interface, USB 2 interface. Okay, 16 channel 10-bit ADC. And here's a pinner if you're interested. So then that accounts for all these interfaces that you can see here, we've got USB 2 with data and power. The power goes to the CL4056 lithium-ion charge IC. You've got a keyboard interface. And then you've got these two 8-bit shift registers. Now, I don't know whether they're kind of daisy-chained, and then they drive the LEDs, or whether they're in parallel. I'm not so sure. You've got your SD card interface for playing back media or recording audio, your auxiliary input into your DAC. You got your BT interface, Bluetooth 5. You got your LCD controller interface. Now you have the stereo in headphone output directly from the chip. Remember, it's got a built-in headphone amplifier. And then a mono interface to this audio amplifier, this LTK5302, which is a mono amplifier. You've got a metal block, which is a mystery. And the last component is a brush. And there we have it, the metal block and the essential brush. I'm going to put in that mystery metal block back into place, and then we'll put this thing together and give it a whiz. Hopefully it still works. Really, I should have tested it before I opened it, really. Well, if it doesn't work, I can just send it back. Nobody will know while I've opened it. Now, when I was putting this thing together, or started to put together, I noticed that the display dial was a bit wonky. It didn't seem straight, and there you can see why. The potentiometer is not straight. I'm sorry, I can't deal with that. I can't deal with it, so I'm going to have to fix it. It will irritate me forever if I don't. I think I could just heat up those tabs which provide support to the potentiometer and put a bit of pressure underneath and release it a bit. That screechy sound when I'm liquidizing, making the solder molten, is a good sign that it's moving. It's looking better. Maybe a little bit more. Bit of pressure underneath. Heat it up, wait for the squeaky sound. Yeah. Should be about it. Bob's your uncle. Done. There we are, proper job. Maybe the speaker wires back on. Power cable's done. Battery in now, the moment of truth. Have they sent me a good one? Well, the lights are on in the back. They are mood lights because you need those. Power button. Well, hey, it works. They sent me a good one. Thank goodness for that. Now what I'm going to do now is find out what the resonant frequency is of that passive driver on the back. I got it at around 4 Hertz. Can you see that passive driver moving? If you're wondering how I'm connecting this, I'm using Bluetooth from my phone, which has got this amazing little app doing frequency generation and stuff, signal generator. So I'm bringing the frequency up, and where it vibrates most, I'm going to assume is the resonant frequency. Wow, that is powerful. The little radio. So there's around 52 Hertz, in case you're interested. There we are, sounds like a V8. There you have it. And here is another showcase of the amount of bass from this thing. I haven't got the sticky rubber feet on the bottom yet, but look at it. Look at it moving by itself. This is MC Hammer. You can't touch this. I muted it, of course, in case you're wondering. Now, what's behind this? I had a closer look at the amplifier chip. So it's an LTK5302. And as you can clearly see in Chinese, the interesting thing about it is it's got some kind of voltage boost circuit. Can you see that inductor there? There's big caps to the right. So it's boosting the voltage internally. So not only is it a Class D amplifier, it's got a voltage boost circuit as well. And if you look in this table, it's got a boost voltage selection pin, which is this pin here, pin 1, V select. And you can set it either 6.5 volts boost, which you should measure across that capacitor or capacitors, or 7.1, depending on that V select. Sorry, 7.1 or 6.5. Now, question is, how do I tell what voltage V selects gets you what boost voltage? Let's have a look. Oh, here's a table showing the various, up to 11 watts. Can you get that? If you've got a 2 ohm speaker and you've got a 7.1 volt boost voltage. 11 watts from that little thing. Well, I assume we haven't got that because we've got a 4 ohm speaker and it's only rated at 5 watts. So I'm assuming we're somewhere in this table under 5 watts. So I guess it's the bottom one, 4.5 watts we had there. And here we are. Right, so if V select is between 3 and 3.3 volts, we get 7.1 volt boost volts. And if it's less than 0.5 volts, we get 6.5. Yeah. So what I'm going to do now is I'm going to measure the voltage on pin 1. I've got, let me see what we've got. We've got 0. Measure that again. We're like 11 millivolts, so that's definitely 6.5 boost voltage. According to specs, we got 6.37. Yeah, that figures. Okay, so this little amplifier circuit boosts its supply rail up internally to 6.5 volts from the battery voltage of 3.7. Now what I'm going to do is measure, using this little scope, the peak-to-peak voltage using a dummy load instead of the speaker. We've got 2 4 ohm resistors, power resistors, sorry, 2 8 ohm power resistors in parallel to give me 4 ohms. And then we've got the oscilloscope across that, and then we can use that to measure the peak-to-peak voltage. So I've now replaced the speaker with, or substitute the speaker with a 4 ohm resistance, and I've got 1 kilohertz test signal, and I've increased the amplitude until it appears that it's not distorted as a sine wave. And you see we've got about 11.5 volts peak to peak. And those resistors are actually getting hot. You can imagine this little portable radio is making those power resistors hot and its audio output. And oh, that amplifier chip is damn hot. You notice it's a very noisy signal, but it's not surprising when that amplifier chip is not only a Class D, but it's got a built-in boost circuit. So you can imagine how much noise that thing's producing. And I may not have this scope connected in the most optimal way. So what I'm going to do now is measure the RMS voltage. This is at 1 kilohertz. So the RMS voltage across the load is about 4.16 volts, 4.16 volts. So remember that, RMS. And I'm going to check the battery voltage at that power output. Uh, 3.9 volts. I seem to remember the specs in the datasheet were 4.2, so it's operating a bit under power. So the peak-to-peak voltage, if you recall, was 11.5 volts. So the peak voltage is around 5.75 volts. Now to get the equivalent DC power, you have to take the RMS voltage, which we can get from the peak voltage by multiplying it by 0.707. So 5.75 times 0.707 gives us 4.07 volts, close to the multimeter voltage. So power is V squared over R. So 16.56 we get over 4 ohms gives us 4.14 watts RMS. Not bad. Now I wanted to show you the app, which is pretty good. So
I'm here in Freetown enjoying one of the city's favorite street snacks, coconut. The top of the coconut is peeled off.
So I can scan the frequencies using the app, and then I can store them in memory. It's a nice looking app, nice looking interface. And change band, so now I'm on VHF, whatever band I think that is. Oops, switched it off by accident. Switch it back on. Go to shortwave. Oh no, that's AM. Now on a shortwave. And I can type in the frequency directly. And now I can record, which is a really cool feature, I think. So end the recording. Let's see if I can play this back. That's Bluetooth mode. It's a Bluetooth speaker. That's media playback. Oh, that's PC mode or aux input mode. Bluetooth mode again. Where's media? Okay, media playback. Now I go to the tracker. And there we have it. How cool is that? That's back to the shortwave radio. And there we have it. That's the app, and then we can also synchronize the time as well from the phone to the radio. Now something else I want to show you. is something I'm gonna take around with this. Is this little device I got. It's a little kind of Bluetooth dongle thing, 3.5mm audio plug on it. It's the A60. You can get it for about $6. You can use it in receive mode or transmit mode. The good thing about this is I can put it in transmit mode. I can plug it into the headphone output of this radio, and then I can connect it to my favorite noise cancelling earbuds. So the great thing about using this together is I can position the radio where it gets good reception in a window or something, and then I can be in bed with my Bluetooth noise cancelling headphones and then control the radio from the app. So in summary, I'm quite happy with this radio. It's nice and compact, got a little light on it which might be handy. It's got the recording, media playback, sounds pretty good. Not too many opportunities for mods here. You could make it 11 watts if you put a 2 ohm speaker in it. I don't think I'll do that. It's already powerful enough. Shakes in your hand. Now remember I mentioned it looks like radios from the 1980s which were styled after military communication receivers. Here's an example, or some examples. Look how close that is. Now, one mod I think I may make is, here's another radio that I sometimes take out with me, the XData D808. You see it's got an antenna input on a 3.5mm jack. Here's the antenna cable. See, it's got a mono 3.5mm jack, which plugs in there for shortwave. Now, it'd be really good if this also had the same jack on it. It doesn't have any antenna jack. But I think you could put it on the top there, maybe next to the telescopic antenna, and link it. So I think that's probably the only mod that I would make on this. So there you have it. If you found this video interesting or useful, please give me a like, and please do subscribe if you'd like to see more videos like this. And until next time, take care of yourselves and happy listening.